Hi, and welcome to another Hopper on microcontrollers video. Hopper is a modern curly brace and semicolon language similar to Java or C Sharp, but designed to run on small devices like these RP2040 devices here. These are like Raspberry Pi Pico type devices. And it's got a full development environment running on Windows, complete with a debugger that just works down the serial port. This video is to show an example program for people who are familiar with MicroPython. So I found this sample on a Pi Pico Facebook group where I was sort of reading and posting about the Raspberry Pi, and I found this relatively small and simple version of Breakout, the game, written in Python. So I ported it to Hopper to show how you do the same things in Hopper. So it's using classes. So it's got a class for sound, which I didn't port because none of the devices I have here, I've got 3 Waveshare devices with buttons here, these two in the background. They have joysticks and buttons and screens, and they're hats or shields that sit on top of a Pi Pico. And then I have this third one over here. Same idea, Waveshare, sitting on top of a Pi Pico. And this here is an Adafruit feather with a OLED Featherwing, because I made this program work on OLED type screens and on TFT screens. That version that's running in the background is running in sort of test mode, where the ball can never go past the paddle, even if, I mean, you can move the paddle on it. You can move the paddle up and down, but it doesn't matter. It's in test mode. It just bounces off the bottom, irrespective of whether it hits the paddle or not. It was a good way to test the system. And that bright bit up there is actually, it does actually have the score in there. And you can see it better in real life than on this video. Anyway, back to the example. So they had a class for sound. I don't have sound on any of my devices, so I haven't done that yet. They've got a class for paddle, of which they only create one instance, because there's only one paddle. Same for the ball. And the ball does the collision testing, the head testing. Then they have a class for brick, and they create a whole array of bricks for the wall. And then they've got a bunch of global methods like this, calculating the angle when it hits the paddle and jumps off the paddle, which uses a bit of trigonometry. And then they have a big game over method here, which is basically the setup and restart. And then this while lives thing here, and while true is the endless loop at the bottom. That's actually the gameplay. So it runs around in circles, updating, sort of moving the ball, checking for, so move the ball, move the paddle, check for collisions. Did you hit a brick? Are we at end of game, etc., and then run around to the beginning again. Right. So let's see how I ported that to Hopper. This is the Hopper IDE. It's an editor that's also written in Hopper, and it has a debugger as well. So I can start this one here as well. If I press the button, it'll start. And I can try to move the paddle on while I'm playing live here, but it's hard to do that on the video. I'll just let it randomly, by luck, hit the paddle or miss the paddle. You'll see the game in play. Let's start it again. Okay. All right, while it's playing, let's have a look at how I implemented it. So I also implemented a set of classes. Hopper doesn't have classes. It has units like Turbo Pascal. So I implemented a paddle class, just like the paddle class in paddle unit, just like the paddle class in the Python version. And because there's only one of them, I can use the global members of the unit as its properties as if it were a class. And so that's the paddle implemented, very similar to the class in Python. Similar for the ball, and I moved that global method in here to calculate it's where it belongs, the ball hitting the paddle. I added a bit more sophistication in terms of well, I did that in the, yeah, anyway, it doesn't matter. I refined the gameplay a bit. And then I did the collision handling here too. I have two collision handling methods because they need to be type specific based on whether the ball has hit a brick or whether it's hit the paddle. And then I did something different for the bricks because there's more than one. So I made a unit called bricks. And inside the unit called bricks, I used a record for single brick and I made a list of bricks. So when you recreate the wall, it creates the bricks. And I optimized it for a couple of different screen sizes to end up with the aesthetic looking set of bricks. Most of the configuration I did for these different devices, I could do sort of generically, but this, I couldn't find a way to do a decent job generically. It was too fiddly to try and get the bricks to look good on the screen, which they do. I mean, you don't want the bricks to be too thin, too thick, come down the screen too far. You also don't want too many bricks because the actual collision processing time affects the speed of the game. Anyway, this is how I randomly choose the colors. So I've got a random, I called. I also do something different to the Python version in that I keep a list of the used colors, so I don't use the same color twice, even if I hit it randomly the second time. I've got a setting here to make the bricks offset if you want them, so if you want them staggered. Anyway, yeah, very similar to the Python. And then let's go look at the main loop. So the main game loop at the bottom, the sort of infinite loop, is down here. And it's in the main for Hopper is called Hopper. And then it's got this infinite loop here. And the second internal loop is counting through how many lives you've got left before you let your last ball go past. And there's a bit of code in here to make it behave efficiently on OLED displays as well as on TFT displays. And that's my gameplay loop. And I had to put a delay in the Hopper version because without this delay, the game's way too fast. I don't know why there's no delay in the game loop of the Python version. Maybe the Python's just slower, so it still works. But it's ridiculously fast if I take the game loop out. And the one in the background, I think, actually that's difficult to tell too because that's an OLED screen, the Adafruit one. Configuration. So to set up for the display, you just set up the options for your display, like whether you want it in portrait or landscape, or whether you want to flip the X and Y axes. And you do this so that, when you're playing this game, where do you want the joystick, relative to your device, and where do you want the buttons? Which buttons do you want to use? So you might want to flip the display around, but other than that, you call device driver begin. And that's that for initializations. And then, because these are all different in terms of how so I've got these four Waveshare devices. I've made them all work so that the gameplay is good and it looks good. And then I also added the three Waveshare devices and the one Adafruit device. But they all have their buttons in different places, and they call them different things. So I made some methods for left button, right button, and the restart button, and configured them differently depending. So this is where the most configuration is for the different hardware. This and deciding how big a brick should be. Because all the other configuration, like the size of the ball, the size of the paddle, all that stuff, I could make generic. I could just do it based on how big the screen is, how wide is it, and how high it is. All of it could be generic based on the screen size, but the actual brick layout was harder to do. Anyhow, and then the drawing of the text at the top of the screen for the score and the game over and all that. Let's go have a look at that. So if I right click on update score, it'll take me to the update score method. There we go. Yeah, this needed some configuration as well. So I don't put as much detail. There's not as much width in the screen. So if you're looking at this one, you can't really see it that well on the screen. Yeah, but in the top of the screen, it also says score and the number of lives. And I had to sort of squish it down because there's not much width there. And so that's what this is about, is just making it fit well. So it's basically putting a blue rectangle up top And I also made this all work correctly in monochrome, so your foreground color needs to be black if you're in monochrome, whereas on the color one, the foreground is white and the background is blue. Um, you'd end up with white on white if you didn't do this. This is the only place in the entire game that I needed to do something for monochrome colors. All the rest sort of works generically, because most of it's relying on black. The only difference is when I had a background color here for the text. So yeah, this is how it draws a rectangle, a blue rectangle, and then it uses screen print. It moves the cursor to where we want to draw and then uses screen print to do the printing based on locations. And then in the game over, we also do some text updates. A little bit of work here to calculate where the middle of the screen is and how wide the string is so that it can draw. If you look at that red box that's flashing on the LCD right now, it's half a character higher and half a character wider than the actual text. And instead of using screen print, I'm using screen draw. And screen draw takes coordinates rather than columns and rows. So it takes pixel coordinates rather than text cell coordinates. So you can put text anywhere on the screen, not just in the cells. And that's what that's about. And then this is the sort of press the start button thing. Yeah. Anyway, this is the demo. I'll put a link in the description to the source code of this and the Python source code on GitHub so that you can have a look at them and see how various stuff is done in here. Because this is basically the makings of a little game kit. You could, a lot of the games that are similar to this, like Tetris, for example, doesn't need any more than this to make it work. Similar games, you could just look at this code and say, oh, that's how you do it in Hopper. Let me make a Hopper game. Anyhow, look at the links in the description. Thank you for watching. And I look forward to your feedback.